The purpose of this video is to put together everything we have learned in Vector 6 and try and put them into a one-page quick summary. Okay? Let's recall, Vector 6 is all about finding angles, points, and distances. Without further ado, let's jump straight into it. What are the types of angles you can find? Okay? First one, angles between two lines. Angles between two lines. Now, if you want angle between two lines, if you look at these two lines here, we make use of the dot product because if you recall the definition of dot product, then this is dot product u dot v is mod u mod v cosine theta. So we make use of that, and therefore we can easily find cosine theta. However, very often the question always asks for acute angle. So when you take inverse cosine, you may or may not get an acute angle. If you happen to get obtuse, you take 180 minus that. You happen to get acute, so be it. That's that. Yep. So that's for acute angle between two lines. Usually the question will ask for acute angle. Okay, that is what usually question asks for acute. So which is this one? Yes? Okay. Now, angles between two planes. What about angles between two planes? Look, the approach here is very simple. If I zoom in a little, this is the side view of a plane. We have plane 1 with a normal 1 here, and plane 2 with a normal 2 here. Now, in order to find the angle between two planes, actually you want this. If you look at the side view like that, alright? It's the same as finding the angle between the two normals. So we don't worry so much. All we need to do is to find the acute angle. Usually, again, the question will ask for acute angle between two planes. It's exactly the same approach as finding angle between two lines. So it's the same cosine theta. This time you take the two normals. What about angle between line and plane? Now this time it's a little bit different. Let's summarize it like that. Okay, if you have gone through the lecture, all we need to do is to do this. You want this angle between line and plane, right? Let's do a side view now here. Let's do at the bottom diagram side view. You essentially want beta, correct? So all I need to do is to find the acute angle alpha between the line and the normal. So this is the normal. Correct? This is the normal. This is our line. So what first of all we do is to find the acute angle. I cannot stress it more. We are trying to find acute angle. Now you will see above. How do you find angle between two lines? You find the acute angle first. After you find the acute angle, then you can find beta. Because you are sure that alpha is acute, you take 90 minus alpha, you actually get your acute angle between the line and the normal. If you really need to practice, you can take a look at question 1E. Okay? Yeah, to practice. Now, let's go back here. Now an overview. So we've completed how to find angles. Essentially, two lines here, two planes, and line and plane. Now let's go on to finding points. Now essentially finding points, you have a lot of points there are actually 4 types of points that we will learn how to find. Now A and B, I would say they are related. C and D are related. How? Now, to find foot of the perpendicular from a point to a line, later on I will demonstrate how to do it, but in this one page summary, I'm not going to put it in. Later I'll work through with you. Alright? Next, we will find the reflection of a point in a line. So, now to find the reflection of a point in a line, you must first find foot of the perpendicular. That's why I put an asterisk here. To find reflection, you must first find foot of the perpendicular. Why do I say that? Essentially, it is about this diagram. If this is the point that we are interested in, you want to find the foot of the perpendicular here. Okay, in this one can be a line or the plane. Correct? Side view of a plane. First, if I want to find the reflection here, the reflected point, I must first find foot of the perpendicular because it is such that this is equidistant. If I can find F, then I can find A prime because F is definitely the midpoint between A and A prime. Right? So, in order to find the reflected point A prime, I must first find F. After you find F, then you use the midpoint theorem. You rearrange, make OA prime the subject. You can find OA prime. Never mind, if you are not very sure, it's alright. I am going to immediately now use an example to illustrate. But before that, let me just show you, actually, there are essentially just two methods to solve this. Okay, there are essentially two methods. One is using simultaneous equation, one is using the idea of projection. Let me demonstrate it here now using question 2. Okay, find the coordinates of the foot of the perpendicular 703 to the following. Now I'm demonstrating line. Okay, this is tutorial question 2a. Okay, question 2a. So I'm going to demonstrate the first method. Okay, yeah, method A. So I will very often, I think it's always useful to give me a diagram. This is the line, and then you have a point. I call it a point B, for example. 2, 9 minus 2. If I have a point, I usually will label it in coordinate form. Then the direction vector, is 1, 2, minus 1. So method A works like this. I'm actually going to find the point F. Method A works like this. If I know this point F, OF, since it lies on the line, F must lie on the line, OF must be equals to 2, 9 minus 2 plus lambda 1, 2 minus 1 for some lambda. I deliberately write for some lambda because very often we say lambda, it means the equation of a line where lambda can be any real number. But in this case, actually, lambda is just some number we do not know, but it takes on a specific value because F is a specific value. Then, since F is the foot of the perpendicular, can we therefore say that actually AF dot 1, 2 minus 1 actually is equals to 0 because it is the foot of the perpendicular. Yes? So what is AF? AF is OF minus OA, which is this. OF minus OA, which is 2, 9 minus 2 plus lambda 1, 2 minus 1 minus 703 dot 1, 2 minus 1 equals to 0. Now, of course, this is not difficult. Yes, I think this is clearly not difficult. Then you will just minus. You will get a minus 5, 9 minus 5 plus lambda 1, 2 minus 1 dot 1, 2 minus 1 equals to 0. Again, let me explain why I don't combine this one and this one. Because later on when I do this, I take this dot this, I get some whole number. It's a lot easier. Alright? I will get 18 plus 6 lambda equals to 0. Therefore, lambda equals to minus 3. Now what does minus 3 mean? Now minus 3 will substitute it back in here. Therefore, OF is equals to minus 1, 3, 1. Because minus 3 you substitute it back here. Because OF is this for some lambda. So that's method 1. That's method 1. So what is the method 2? Method 2 essentially is using the idea of, method B is idea of projection method. Projection method. Yes? What is the idea of projection? Again, I label here. A is 7, 0, 3. I have the line. Again, I call this B again. Yes, which is our 2, 9, minus 2. And again, this is the direction vector, which is 1, 2, minus 1. What we want to find is this point F. Now, the idea of projection is this. If I know what is B, I can actually find what is BA. It's actually OA minus OB, which is 703 minus 2, 9, minus 2, which is 5 minus 9, 5. I don't think this is a problem. Then we use the idea of projection. Now BF, which is the projection of BA, if you look at this very carefully, BF is actually the projection of BA onto this vector 1, 2, minus 1. Yes? So it is actually BA dot unit vector of, I call this U, and U, where this is U. This is the direction vector of, this is the direction vector of the line. This is the line. Yes? So, not difficult now. Yes? Therefore, it is 5 minus 9, 5. Let's do this. Dot 1 over root 6, 1, 2, minus 1. 1 over root 6, 1, 2, minus 1. Then we work it out. Yes, this dot this, eventually you will get a minus 3, minus 6, 3. Now this is not the end yet, because what you have found here is just what is BF. Then from there we can obviously know what is OF. OF is actually OB plus BF, which is minus 1, 3, 1. So to summarize, there are two methods, all right, to finding the foot of the perpendicular from a point to a line. Either you make use of the fact that AF is perpendicular to the line, or you use the idea of projection. Yes? So let's go back to the summary page now. Here. See? Here. We have done this one. Simultaneous equation. Essentially, it's not simultaneous, but it's just equation and use of projection. So we have completed A. What if now the question, let me extend the question a little. How do you find the reflection of a point in a line? Say, for example, if the question asks, what is the reflection of the point A in the line? Which means, what do you want? You essentially want what is A here, line here, A prime. What is this? So as I said just now, it's very simple. As long as I can find F, which I have found here. Yes, as long as I can find F, then it's very simple, because OF is actually OA plus OA prime divided by 2. Done. Yes? Alright? Great. Now let's go back to the summary. Alright. Sorry, let me do this here. Alright. So, we've done that. Now we talk about foot of the perpendicular from a point to a plane now. Plane now. So here it says, okay, look at question 2b. Yeah, again two methods. Again two methods. Instead of a line here, now we talk about plane. Yes, instead of a line here, we talk about a plane. Again, two methods. Alright. One, simultaneous equation. How do I put it like that? Look. This is A 703. Let's call this method A, yeah? Yes, 703. And I've got a plane like that. Essentially, I want the point F. I want to find where is F. What is F? So, can I form the equation of the line AF? Actually, we can. Why? Because we know the normal vector is 1, 1, 2. This is the normal. Correct? This is the normal 112. So line AF has equation R equals to 703 plus lambda 112. Lambda belonging to real. All agree? If I know the line equation of line AF, I know the equation of the plane. I think I don't want to go through solving line equation of line and plane. This one in this vectors 5 stuff, I don't want to go through. You will get, therefore, OF equals to, I give you answer, 5 minus 2, 1. This one you figure out on your own. I don't want to go through. That's essentially method A. Because you just form equation of line first, then intersect with plane. Intersection between line and plane. Done. Method B is using the idea of projection, but you must be very careful when you use projection now. Again, this is the plane, this is the point A, 703. You got to find a random point B. This time you got to find a random point B. How do you identify a random point B? How do you identify a random point B? As long as you can satisfy the equation of the plane, we are good. So randomly, I will find 100. It may not be 100, but I think 100 works. Or you can be 010. It doesn't really matter. I choose 100. So all I want to do is to take this one. I want to find F. And I know the normal vector is 112. So can I find what is the projection of AB? I find AB first, which is 100 minus 703, which is minus 60 minus 3. Can I take AB, project onto the normal vector? What do I get? You don't get BF, don't get me wrong. AB project onto the normal, you will get your AF. So, and the order matters. Whether it's AF or FA, it must. AF is actually the projection of AB on the normal. So, it is actually AB dot n hat. N hat. Again, you must be strong with your idea of projection. Then I know what is AF. So after finding AF, I put dot dot dot. You can try it on your own. Right? AF, you will get a minus 2, 1, 1, 2. After finding AF, yes, then you can find what is OF, because OF is just OA plus AF. There you go, answer. Again, of course, you will get the same thing. 5 minus 2 minus 1. So again, there are two methods here. They are slightly different. Okay, this is the shortest distance between the point, a foot of the perpendicular from a point to a plane. Either you use intersection, or this case, foot of the plane from A to the plane, you use projection. All good? Yes, you must be strong with projection. So I'll pause here for a while. The next video, we will then talk about distances.